Hello everyone. In this part of video, I am going to discuss some of the numericals only. Numerical based on single phase AC system. Numerical on single phase AC system. So here we will see that how we can find the resultant current if two AC signals are flowing in a circuit. Suppose our one current is given like I1 is given as 5 sine omega t, I2 is given as 5 sine omega t plus 30 degree, 5 sine omega t plus 30 degree, and I3 is given as, its magnitude is again same, given as 5 sine omega t minus 120 degree. So these are the three currents, and we need to find the RMS value of resultant current. RMS value of resultant current. Resultant current. We need to find RMS value of resultant current. This is our problem number 1. So how we can find the RMS value of current? Here we see in generally in DC case, suppose three currents are flowing, so it will be added directly. But here we cannot add directly because there is a sine term here, 30 degree angle is there, here 120 degree angle is there. So in this case, we have to solve this problem. So how we will solve? Let us see. So I1 we can write here. It is 5 angle 0 degree, because here nothing is added. Here we can say it is 0 degree. So that is why it is written as 5 angle 0 degree. Similarly, we can write I2 equal to 5 angle 30 degree. Positive is there, so it is positive here. And I3 we can write it is equal to 5 angle minus 120 degree. So now we this representation and this representation both are same. Here very important part is that we can add only when frequency of all current, frequency of all current must be same, must be same. Here we can see that frequency is omega, here frequency is omega, here frequency is also omega. If frequency is not same, we cannot add them. So first and most important condition is that frequency should be same, then and only then we can add them. So now we have to find out the RMS value, but here this value is the maximum value. This is the maximum value. So if we want to find its RMS value, we have to divide it by root 2. So it is I1 RMS value. Again, if we divide here by root 2, it will be I2 RMS value, and I3 RMS value if I divide here by root 2. So these are the RMS values. So now we have to find a resultant current, that is the summation of I1. This RMS value I write here I1, and this RMS value, just taking some other color, this RMS value is, I'm going to write it as I2, and it's this RMS value I am just going to write I3. This value, this whole is represented by I3. So I1 plus I2 plus I3. So we cannot directly add it. There is a certain rule. There is a addition that is called Phasor addition. We will see how to add this relation. So this value we can very easily find out, and the value which is how we will getting. So it value is maximum value is 5. So we just have to go on vector analysis. So we can write here one current that is flowing here and having magnitude 5 and angle is 0. This is taken as reference line. This is our reference line. And another current is 30-degree positive angle is there. So we can write it as, this is also magnitude 5 and angle is, this is angle which is equal to 30-degree. Another current is there whose magnitude maximum value is 5 and angle is minus 120-degree. So I'm taking some different color. So from this reference line, angle should be 120. So 90 is here, and 30 angle if we go, then this angle is minus 120-degree. This is the case. So this is I3 and its magnitude is also 5. So we can write this as 5 angle minus 120-degree. So there are so many methods we can solve this relation. So one method I am going to adopt here. So the using this relation, if we break this current into their sine and cosine component, which you have already studied. So this 530 angle, we can write here its component in this axis will be 5 cos 30, and at right angle its magnitude will be 5 sine 30-degree. So 5 cos 30-degree and 5 sine 30-degree is broken. Now this current is already in the x-axis or reference line. This is our x-axis or reference line. So its y component will be 0. It has only x component. Now we can also break this component. If I draw a line here, so this angle is 90-degree and this angle will be 30-degree. So 90 and 30 will be along this direction. It will be minus 120-degree. So if we break this current in two components here, so one component will be 5 cos 30-degree in negative y direction, and here it will be 5 sine 30-degree in negative x-axis. Negative x-axis. Now we have broken all the part of the current in x and y component. So we can write here total x component. So total x component of current, total x component of current will be equal to, here we see 5 and angle is 0, means this is x-axis, 5 plus another component is 5 cos 30-degree, and there is another component 5 sine 30-degree minus 5 sine 30-degree, because it is in negative x-axis. So we need to solve it, and we will get its value 5. If we solve it, we will get its value, which is 5 plus 5 multiplied by cos 30 is root 3 by 2, and minus sine 30 here is 1 by 2, so 5 by 2. So we will get a value that we can solve it from here, and we will get a numerical value. So here we can solve this and we will get 6.8 ampere. So here we have used maximum value, keep in mind. In similar way, we can also find the total y component. So 5 sine 30 is along the positive axis and 5 cos 30 is along the negative y axis. So positive minus negative, this is just a vector subtraction. So here we will get it 1.8. So total x and total y component of now current is known. So I'm going to draw this two currents, and this current total x component is 6.8 and total y component is negative. So we have to draw in this direction minus 1.8. This is the total y component that is written here I y, and this one is written as total ix. Now, so we have two vectors x and y, so we will get its resultant. So this vector is 90-degree inclined, so resultant of ix and iy will be under root ix square plus I y square plus twice ix I y into cos 90. This is vector just addition of the two vector. So a square plus b square plus 2ab cos theta, and this term will be 0, cos 90 is 0. So ix square plus iy square, if we put this value 6.8 square plus 1.8 square, it will give us, which is equal to 7.07. You can check it. So this is the magnitude of the, this is maximum value. I have used it here, maximum value. Now another thing we have also to find out, that is called resultant vector, what angle it makes with the x-axis. So this axis, let this angle is, I'm just drawing here, let this angle is alpha. So if I'm just taking some other color, so that we can differentiate. So this angle alpha we can find very easily by using the tan. So tan alpha, if you see, it will be minus 1.8 divided by 6.8. So alpha will be equal to minus, the angle will be minus 15 degree. So here angle is known and magnitude is known. Magnitude is how much? 7.07. So this magnitude is known, angle is also known. So now we can write the resultant current like this. Resultant current will be equal to 7.07 sine omega t minus 15 degree. So if we add this three current, we will get, this is the maximum value. But if we want RMS value, just divide it by root 2. So this will be RMS value. So 15 angle is minus, so minus is put it. In this way, we can find the current flowing in the circuit by using the vector component breaking method. Or another method is that we can also directly go and directly find in one line, that I also am going to discuss here. Our three current was I1. I'm just interested to another method. Another method. So another method we have to find, we have just to add first this three current. What was the value? 5 angle 0 plus 5 angle 30 plus 5 angle 120 degree. So one relation we know how to break, suppose if it is R angle theta, so it can be written as R cos theta plus J R sin theta. This j is nothing but, this j means ki imaginary axis that you have already studied. This is real axis in complex number, and this is 90 degree. This is called j axis. J axis, or this is also called imaginary axis. Imaginary axis. So here angle is 90 degree. So this is called imaginary axis also, and this is called real axis. So a complex number can be represented in this form. 3 plus, suppose it is J4. So 3 will be on this axis and 4 will be on this axis. So this is a relation. That relation is called, this is called polar form. Taking some other color. This is R angle theta form is known as polar form. and this form representation r cos theta plus j. This form of representation is called a rectangular form. A rectangular form. So from polar to rectangular is converted, or from rectangular to polar we can also convert. So just using this relation, we can write here 5 cos 0 plus 5 plus j sine 0. This term is broken. Now another, for this term, 5 cos 30 plus j sine j multiplied by 5 sine 30 plus, now this term, 5 cos minus 120 degree plus j 5 sine 120 degree minus. So all j will be included, added together. This j and j will be added together. This value is 0, and all real term, these are the real term. I am taking some other color. So this is the real part, this one is real part, this one is real part, and this one is real part. If you use calculator and you will solve this all real part, adding this three term, then it will come 6.8. And this in j term I am taking different color, and if I am taking this imaginary component, this part, and this part, it will be minus j 1.8, same as in the vector component bracket. So this is our resultant current, and same way we will now, this form is called rectangular form, so we can convert it into polar form by just doing, this is the real component 6.8 square plus 1.8 square minus, this term is minus, and here angle will be tan inverse coefficient of j. What is coefficient of j? Minus 1.8 and divided by real part 6.8. So again, by doing this thing, we will get the same result, 7.07. Angle will be minus 15 degree, which we have already calculated. So next problem I will see in the next video.